So this episode we're going to look at ability events, and we're going to be looking at projectiles because they're a really good example of event systems happening within your ability. And we're going to make something similar to Mirana's arrow, which is a linear projectile. Now, so far up until this episode, we've only been looking at on spell start. But before I explain any of the other events, I want to go and look at the cycle which happening with your abilities when you're casting them. So I've made this diagram which shows you the animation cycle of what's happening throughout the game. So at the very start here, you press a button, and when the button is pressed, it calls on ability phase start. Now then there's a cast point, which is the duration of the animation winding up to the ability to be cast. So when the ability is finally cast, then your function here called on spell start is called. This could be effectively like thinking about real life, is when you kick in a soccer ball, is that you pull your leg back, and that would be the wind up animation. When you hit the ball would be on spell start, like the event is happening, and then there's a backswing which is resetting it back up. So down here is the backswing. Now before we look at the backswing, it's not very important, but what's really important is that the wind up animation during this point between pressing the button and the wind up animation happening, it can be cancelled for whatever reason. Some of the reasons are the player can cancel it themselves by pressing the stop button, they can be stunned, the hero can die, or even they can run out of mana. We don't really care why they ran out of mana or any of these other reasons, but in here there's an other event that's called on ability phase interrupted, which will happen between this point, and that's when your animation gets cancelled for some reason. Now we also have a backswing, which is now for the backswing animation, and what this does in Dota is it prevents you from using another ability soon afterwards. You can do other animations, such as using an item for like a blink dagger. You can walk in another direction, and the difference is that like people will use this functionality called orb walking, which is exploited a lot for higher skill players. So there's no particular event that's going to be called when the backswing ends, the backswing animation, and this is not so important, so that's why there isn't really an event for it. Now on the documentation website, it shows you a few different events here, and it shows you explanations beside them. So for example, here there's a function called on upgrade, and this will be called when the ability is leveled up. Now what we'll be looking at is one called OnProjectileHit, and that's when a projectile is finished. It either hits a target or it's going to reach its maximum distance or some end case scenario. Now unfortunately all the events aren't here, but what we can do is go to the API, and if we scroll down here to see Dota underscore ability underscore Lua, we click on this, it will scroll us down to this section, and if we go down, there's all of these functions that start with on, and any function that starts with on is listening into some sort of event. So these are ones that I've highlighted here are all events. So as you see, we were talking about on upgrade, on projectile hit, on owner died. They're pretty descriptive themselves, and they also have a description on the right hand side here as well on this table. Now what we're going to do is we're going to start coding up our ability, and we want to make a new ability. So let's go to our project folder and go into scripts, npc abilities custom.txt. So open this in our editor. We're going to make a new ability here called my arrow, we're going to call it, and we open and close our brackets. We want to get, this is our template we were using last time, so we'll copy and paste this in, and our script file is going to be my arrow. So that's going to be the name of the file that we're going to make. And we also need ability behavior. So our ability behavior here is going to be a point. So we're clicking on the ground somewhere, and that's going to be how we're going to use this spell. Now we don't care about any of these other factors yet, and we can get them later. What we'll just do for the convenience of this as well, we'll try and make to see if we can do this right. Like let's say Mirana sacred arrow. Let's go to the wiki actually and get this right, just so we have it for the tutorial. ability names, and we go to Marana arrow. It's literally just Marana arrow. Okay, that's the name of the file. That's the name of the ability icon. So we need to go now to our heroes key value file. So we need to add this in as ability tree, and you can put it into any slot you want, but we're doing ability tree, and this ability is called my arrow. This makes sure that the hero is assigned this ability when they spawn into the game. And now we're going to create the logic. So if we go back into our vscripts folder and we create a new file called myarrow.lua, and we open that up too. So now we're creating the logic here, and we just create the class myArrow equals class, and we want to go function myArrow unspell start. And what we want to do is our functionality to go here. Now if you want to make sure that you've linked up everything right, you would go something like print here, and that would just be enough to say that your arrow is working. But we don't know the exact code of this, so we need to go to the wiki, and there's an example up on the API. So if we go to projectile manager, and down here in projectile manager is two functions called create linear projectile and create tracking projectile. These are the two types of projectiles that are in Dota. The linear projectiles are one that fly in a straight line, and tracking projectiles are ones that are like homing missiles. They lock in on the target until it hits them, and they can also be disjointed as well. But we're going to be looking at linear projectiles, so let's open this in a new tab. And here's an example that Valve have given us, but this example has a number of flaws with it. So let's just copy and paste this into our project. And what's happening here is, right, before we care about all of this, what I've highlighted here is a table of all the data that is needed for creating the projectile. And then on this line down here at the bottom is at this, let's just remove this for a second, but this line here is creating the linear projectile and passing in this table that we're creating. So before we look at any of these values in the table, what we're going to do is, we'll look at them right now. We're going to just fix the tab in here, but there's a number of problems with this code for what we want straight away. So the caster needs to be changed to self.colon.getCaster. This gets the caster of this ability. Self is this class, which is my arrow. Now we also have to get the ability here, which is self, and the effect name is the particle effect. Now we'll get to this in a second. Particle effect, particle, can I spell it? There we go. And spawn origin is the point at which the arrow will be created at. F distance is the maximum distance that your arrow can travel, and then after it's reached that distance, it will delete itself. It won't be there anymore. The projectile manager will clean it up for you. Then you have start radius and end radius. This is a sphere that is around your projectile that it determines the size of it. So 64 units is the size, and if you want to make your hitbox for the arrow get bigger as it's traveling, you can change the end radius or the start radius and have these different sizes. So let's say at the end it would be 128, so it's double the width that would be when it starts out. Now heroes like Queen of Pain have an ability Sonic Wave, and Sonic Wave goes outwards, and what Sonic Wave actually is a linear projectile too, even though it doesn't look like it with the particle effect. How it's coded is a linear projectile. Also Lena's Dragon Salve, and you can think about other spells that might use something like this as well. Now the source equals the caster, which we've defined up here, self get caster. Then we have frontal cone and replace existing. I don't know exactly what these do. I think this changes the hitbox and stuff, but we can comment these out because we don't really need them. And then we have unit target team. This is the team that's going to be hit, which was the enemy. We should really be doing this currently in this example, we're hard coding this, but what we should be doing is going in here to our key value file and be adding it in this location, and then extracting it from the key value file within the Lua. But currently in this example, what we're going to do in the tutorial is just hard coding it for now and leave the hard coded stuff. So in the target, the flags, we're ignoring none, and the target type, it's only going to hit heroes and basic targets, so it's not going to hit buildings. Then the expire time is the duration that this ability, the time when this ability is going to end. So it gets the current game time plus 10 seconds. If you want this to be 15 seconds, you want it only to travel 3 seconds, you can just change that to whatever. But we're going to do 10 seconds. It's a good idea to have a timer as well, in case the maximum distance is really long. Because what we can do is we can make our ability, our projectile, fly really, really slowly, and it could take a really, really long time until it gets to that point. But we want it to expire at some point rather than it going on for infinite. Then this value goes delete on hit, which is set to true. So when it hits a target like an enemy hero, it'll get destroyed. We have velocity, which is the direction, and which this is a vector for people who know what vectors is, but there's a bug with this code that's here, and we'll look at it in a little bit more detail. We'll come back to that, but the velocity is the direction and speed that it's traveling at. Then the provided vision is true, which means that the arrow is going to give us vision when it's traveling through the air. And in the vision radius, we're going to just set this to 500, for example, and this will give us vision as it'll define the radius of the vision. So then you have team number, which is the team that gets vision from this ability. So you could change this as well. Typically you want it to be the caster who's casting the ability to get the vision as well. And then finally, we're using this entire table to pass to our create linear projectile. So let's go and run this code. So now that we've loaded in, we see that we have a Marana arrow here, the arrow on the icon. And if we click this ability, nothing happens. And the reason why nothing happens is because we never set a particle effect. This ends up being a section on its own, which I'll be going into more detail in another episode. But for now, what we're going to do is go and find the Marana projectile within the asset browser. So if we open up the asset browser and we type in Marana, we'll get a bunch of particle effects that are here. Now, what we want to do if you go to, by default, I think it's on all. So what you want to do is we only want to search for particle systems. So the asset browser is kind of looking through all the files that are there for Dota, and we want to look at particle systems. Now there's a good few here. So you have Marana spell crescent arrow. So we're going to just use this one. You can use the default Marana arrow, but this is the one what we're looking for. And if you're wondering what all these different files are, just a brief explanation. Particle effects are built up of lots of smaller particle effects, and they're all combined in together. And you want to find the parent one, which is all the childs combined together. And this one here, Marana spell crescent arrow, is the parent particle effect. So we need to go back here to our particle effect and copy and paste this directory. We also need to pre-cache this, which I'll explain in further detail in another episode. But what you want to do to pre-cache it is go into your add-on underscore game mode, and there's one pre-cache resource here, and it's pre-caching a particle effect. And what this basically does, in a brief explanation, is that it ensures that this particle effect is loaded up by all players when they start up your custom game. And you do not need to do this while you're in the tools. And the reason why you don't need to do it in your tools is because you're the host and the server automatically loads these particle effects. So you generally want to pre-cache and for everything, but we'll go into pre-caching more in another episode. But now if we use our ability, we can see we have the arrow going out flying each time, and it fires in the direction that we're clicking. But I was saying that there was a bug with the direction that it's going. So notice how my hero is pointing to the right here, and I can fire an arrow to the right. Now let's notice how the forward direction of my hero is pointing off here to the right, and we're going to click on the opposite direction, and look what happens with the arrow. Look at the direction the arrow goes. Why did it go upwards at 90 degrees instead of the full 180 degrees? Now if we do that again, what's happening is our hero is turning around, and it's using the current forward direction of our hero. Dota has turn rates, so each hero has different turn rates. You can turn the turn rates off if you want, but turn rates are something that you do have to take into account, and we're going to end up fixing this. So let's go back into our code, and we have to do some logic here for this as well. So the problem is that we're getting the forward vector, the current forward position of our hero, but they haven't fully turned around. Now if we go and we get the self.get cursor position, let's see, we need to make sure that we have this syntax correctly. Get cursor position, which is getting the point of the cursor, local cursor point. And we'll go into vectors maybe in more detail in another episode. But what we need to do is calculate the positions of where our arrow is going, the direction of it. So caster.get abs origin, local caster point. So what we need to do is go local direction equals cursor point minus the caster point. And what this is doing is it's getting the direction of a vector in the relation to the caster's as being the origin point. So this is kind of like hard to explain without looking at vectors, but what we're doing is we need to go to direction, and we need to make sure that we normalize this. Direction normalized. So then we have here, instead of with this code, you can get this on the GitHub project if you want. I'll explain vectors in another episode, but this is just for now. You can just copy and paste this or whatever you want. So direction down here, our velocity is the direction multiplied by 1800. So this is going to get us our speed, and we're going to restart this and see how this, if we coded this up correctly. We'll try and reproduce this bug. We click here and it fires our arrow to the right, and we click the other way and it turns us around and fires the arrow in the correct direction. So we've after fixing that bug. Now let's say we wanted to make our arrow travel at a different speed. We were using 1800, which is a hard-coded value. And let's say we want to constantly change this, or someone else wants to change it in the future or whatever, right? So now if we go back to our abilities custom .txt, and we're going to make an ability special. So if we get this ability special here, we put this in here, and we just want 1, and we're going to do this as an integer. We change this to, we call this whatever we want, we call it speed, and we're going to go 600, and we're going to have the arrow moving at 600 units per second. Now let's go back to my code now, and we need to get this for our ability. So if we go self, what's this function, get special, what's it called, get a special value for, this is the name of the function, and we want to go what was it called, speed, and we're going to go local speed. We're going to store it as a variable named speed, and instead of multiplying by 1800, we're going to go with speed. Now you can do this, there's different ways of getting each one of these values in the documentation in the API, and we were looking at some of those in last episode as well, with the last, or it wasn't last episode, it was the one before it, and we were looking at how we can extract the values from the key value file. So when we load this up, we should see that the ability now will have the arrow traveling at a slower speed. So let's level this up. We fly it, and look how it's moving much slower, and it's using that value that we got from the key value file. So now we're going to write the logic when the projectile hits. So in our Lua file, we have been using onSpell start and listening to this event. Now what we want to do is create a new function and call myArrow onProjectileHit. This is the other event that we listen into. Now if we go and we look at the documentation in the API, it says onProjectileHit requires a H target and a V text vector of V location. So what we do is we go V target and, or sorry, H target and V location. And why these names are like this, you can name them anything you want. You can name it Johnny and Billy or whatever you want. But the reason why this H is here is to give you an idea that this is a handle, which is a unit handle, and this is a V, which is a vector, which is a location that's at. But we won't be dealing with that so far. But what we do care about is the H target, and H target will be, these are specific to this function of OnProjectileHit, and H target will be nil if we hit nothing, if the projectile goes to the very end and expires. Now print expired, and we'll write arrow expired, we'll say. Now if the projectile ends up hitting something, we want to print something else. We're going to print out the arrow hit and who we hit. So we go H target get name, and this will print out the name of the target that we've after hit. Now we do have to return a value based on what we're doing. So if it expires, this function will automatically just destroy the arrow. Now the other thing you want to do is, now what we care about is returning a value. So if you are deleting your arrow when it hits something, you need to call return true. If you don't do this, your arrow, even though you've specified delete on hit, it will not delete it, so your arrow will fly through the enemy and it won't get hit. So you have to return true if you're destroying it. Otherwise you return false if the target is nil, which meaning that the target. So now one thing that's really important is making sure the arrow gets destroyed. This is a bug that will happen if you don't do this, and what you have to do is return true. And if you have this delete on hit and we call true and return true, it's going to destroy this arrow when the true is returned. Now if we return false, the arrow won't be destroyed, but because our arrow expires after a certain amount of time, it will, let's say there's two scenarios that will happen. Either one, that it will hit a target, or two, it will expire because it either ran out of time or reached its maximum distance. So if it expires, it doesn't matter if we return true or false, so because it will automatically delete it regardless. So we're going to return true here because we're destroying the arrow. So let's go and restart this and run our code off into the distance, and once it expires, it'll write into the console arrow expired. Now if we go back again and we do this and we hit the enemy, we'll fire this in this direction and it hits the enemy, the arrow gets destroyed when it hits them. If I show you again, the arrow goes and hits the enemy and hits them. Now in the console, it's wrote out the NPC Dota creature, which is the unit that we've hit twice. Now this is just a basic example of the event system with her ability, and in here where it says print arrow expired, you can go and do the whole applying damage stuff that we did in previous episodes. And other thing that I would just mention is that you can also make sure that you don't hard code these things if you are doing your arrow stuff. Now one thing I want to touch on very briefly is the other types of projectiles. So if we go back to our projectile manager in the documentation, down here is create tracking projectile, and tracking projectiles are like homing missiles, and these are very similar to your linear projectiles. So the difference is that if we look at this example that Valve have given us, when we click on into this info, it does pretty much the exact same thing. It calls this function down here called projectile manager create tracking projectile, and it passes in a table, and this table is specified here and all the values that are there. So one of the things that can happen with these linear projectiles, as they're homing missiling in, you can blink, and when a blink is used, the default blink in Dota, it disjoints abilities, and any other some sort of mobility spells can disjoint things as well. So setting this to true, dodgeable to true, it will disjoint this ability. So this is ability events in a nutshell. If you want to see more custom game tutorials, make sure you subscribe, and we'll be moving on to modifiers next, which is about stuns and other disables onto the enemy.